Okay, so what you can see is this is Digestive System Chapter 22. This lecture is in place of the lecture for Tuesday, July 21st. I am currently away from the campus, and I'll be back next Monday. Between now and then, if you happen to have questions, you can always ask Tom. Tom will be able to answer anything that you have questions about. You can also email me. I'm not sure what kind of availability I'll have with internet access. However, I will do my best to get back to you in a very timely fashion. Over the next couple of videos, we're going to cover the digestive system, chapter 23, which is nutrition, and the urinary system, which is chapter 24. For today's lecture, we're going to start out on the board, and I'm going to go through and I'm going to lay out for you the digestive system pathway, starting from oral cavity all the way to the exit. During this particular portion of the lecture, there's going to be a lot of writing on the board, so you might want to stop the video at this point and go grab a number of different colors. I've got 8 out that we're going to go ahead and use. At any time, if this is moving too quickly, you can stop the video, you can go back, you can watch it multiple times, whatever works for you. In this process, please make sure that you are writing down notes off the information, because again, even though I'm going to put the PowerPoint up for you, what you'll notice about the test questions is they don't come directly off of that PowerPoint. And so you need to be taking notes as we go through, not only on this, but we're going to switch over to the overhead here in just a few minutes and finish off the lecture on the overhead. What else do I need to tell you? Make sure that you have a number of colors as we move through the process. You're going to see me move in and out of this video just because I've got my pens over here on the side. There will be a ton of information that goes up on the board. There are multiple organs that serve the digestive system. And within each of those organs, you have multiple component pieces that make up that organ. For example, the large intestine has 9 different component pieces that make up the intestinal system. So as we go, I'm going to color code them so that every color that you see up on the board indicates we're looking at a different organ in that organ system. You will find listed components. For example, we'll have 9 of them for the large intestine. So all of those colors that you see correlate into one large organ, okay? Seems like there was something else I was going to tell you. I'll figure it out as we go. Okay, so I'm going to take this down off the digestive system. Clean that off, and we're going to start right with the oral cavity. You'll see me just checking real quickly to make sure that I've pulled all my parts and pieces together, because this is such an extensive drawing. I want to make sure that we get all the information that's supposed to be up there. So we're going to start right with the oral cavity. Okay. Within the oral cavity, we have a number of component pieces that make up that oral cavity. Number 1, lips. Number 2, tongue. Teeth. Hard palate. Soft palate. Tonsils. And salivary glands. When we get into the overhead lecture series, I will go through each one of those and we'll break them down into their component pieces, so that we'll talk about function and dysfunction and what very important portions they serve with chemical and mechanical digestion. Okay. Now, at the back of the oral cavity, and this is the one that one structure that I have not yet put up, it's called the uvula, and it's that punching bag looking structure that hangs off of the roof of the mouth into the back of the oral cavity. It is there to regulate the size of material that's moving out of the oral cavity. So as you put food into your mouth, that gets broken down, number one, by mechanical digestion, so teeth and tongue and lips, moving that material in there to break it into smaller pieces. It also is being doused by a very mucousy based material called saliva that has a number of enzymes that are beginning to break down carbohydrates. That mushy material, that ball of food that leaves the mouth is called a bolus. Now, the bolus will work its way through the uvula. So we've got our bolus, and it will work its way through the uvula out onto the other side into a structure called the pharynx. 3 different parts of the pharynx. Number 1, the nasopharynx. And the nasopharynx, because it's in the nasal cavity, or it connects the nasal cavity, is actually connecting the respiratory system to the pharynx. Okay? The other part of that, second part, and this is really where we are right now, is called the oropharynx. And then the third part of the pharynx is called the laryngopharynx. Now, from the laryngopharynx, we actually would be traveling into the trachea. And the trachea being part of the respiratory system. We don't want food moving into that trachea and into the respiratory system. So we've got a little structure that hangs over the top, a little trap-like door. That will close over the top of the trachea to prevent food from entering into the trachea and pushing food from the pharynx into this next structure called the esophagus. And the esophagus is nothing more than one piece of smooth muscle tubing that directs the food out of the pharynx and into the stomach. Real quickly, let's make sure we've got our crossroads. With respiration. Okay. From the esophagus. And again, the only thing that occurs in the esophagus, nothing other than the movement of food and the dropping of food into that stomach. So there is a contractive wave that occurs on a regular basis. Hey.
Hi.
How are you?
Good. You videoing?
Yeah, it's
Okay.
fine. You can clean now.
Huh?
It's fine. You can clean.
Okay.
No big deal.
I'm not gonna be here tomorrow or Friday.
That's fine. So the only thing that actually really occurs in that esophagus as food moves through is called peristalsis. And peristalsis is nothing more than that contractive wave pushing food down that esophagus into the stomach so that food can be delivered. And again, we're talking about a bolus up to this point still. So it's moving that bolus into the stomach, but before we get there, right at the bottom of that esophagus, boom, right there, is a little trap door. And it's nothing more than a piece of rounded muscle that opens and closes to allow either food in or food out of the stomach, called the lower esophageal sphincter. You'll also find that it's called the cardiac sphincter. And it's called the cardiac sphincter because it sits right next to the heart, so that if that cardiac sphincter is not working correctly, food coming back up into the esophagus will cause heartburn. Okay? Moving that bolus into our stomach. And once food drops in, that bolus drops into the stomach. Okay, so we've got our bolus coming in. That bolus begins to be just absolutely doused with hydrochloric acid, extremely acidic in its nature. And this is where we have the initiation of protein breakdown. That bolus is covered with that hydrochloric acid. And when we look at, in a few minutes, we'll be looking at the 3 types of muscle that are there to allow for optimal amounts of contraction to spin that material in 360 degrees and begin breaking it apart. And as it breaks apart, it becomes kind of a mushy mess. Okay? So our bolus, by the time that it goes through all of that chemical infiltration and that chemical digestion, comes out the other side, and that bolus is now called chyme. When we get to the lecture series on the board, we'll talk about the 4 types of cells that you'll find in the stomach. We'll talk about the mucus that's infused into the stomach. We'll talk about the pepsin and pepsinogen that creates or breaks down that protein-based material. There we go. That's a little better. Clinical conditions that we find in the stomach, first and foremost. We have already talked about the lower esophageal sphincter not working correctly. And when that lower esophageal sphincter does not work correctly, we end up with a condition called GERD, gastroesophageal reflux disease. Your patient will call it just reflux. And reflux is a clinical condition in which that sphincter no longer opens and closes properly. And so food that has been heavily doused in that hydrochloric acid will return back up through that lower esophageal sphincter into the esophagus, maybe into the pharynx. But the issue becomes, because it's been so heavily coated in that hydrochloric acid, it will cause significant amounts of damage to the cell structures in the esophagus. And so we're concerned about conditions that eventually could lead to esophageal cancer. Esophageal cancer also can be generated by things coming through the oral cavity, environmentals, things like chew, any kind of tobacco product that is prolongingly left in the oral cavity into the pharynx, some of that juice being swallowed down into the esophagus. The other condition that we'll find in the stomach, called H. pylori. Helicobacter pylori is a microorganism, it's a bacteria specifically, that will infiltrate the walls and the pits of the stomach, causing irritation to those cells that are there, eventually causing what's called an ulceration. Originally, ulcerations were thought to be the product of stress and dietary intake. Not that they can't be. However, we have now proven that there's a clinical condition in which a microorganism called an acidophile, living in a very acidic environment, has been allowed to prolong and to embed itself into the walls of the stomach, irritating the stomach and actually removing the lining. Diagnosis now is through, it's a breath test. In which they can find the residual H. pylori coming back up through the esophagus and into the oral cavity. Treatment is a fairly easy regimen at this point, where we turn off the hydrochloric pumps with something like a Nexium or a Prilosec, and then infiltrate a large dosage of antibiotics over about a 6-week period, and it seems to work very, very, very well. Okay, and so we'll discuss that as we get to the lecture series. Food that is moved through that bolus now has become chyme and will begin to exit out of the stomach. And again, there's a little trap door at the edge of the stomach that will regulate what is allowed to pass through that stomach or out of that stomach. So basically, we're compartmentalizing everything into one area. We want to make sure that hydrochloric acid isn't being emitted back up into the esophagus and then rolling out into the duodenum. So we want to keep everything kind of compartmentalized so that we can keep everything moving in a forward direction. This guy right here is called the pyloric sphincter. And we'll talk about the 4 parts of the stomach in the lecture portion, and we'll break that down for you. You will need to know that for the lecture exam. You will also need to know that for the lab exam. Okay? So food that exits out of the stomach and into directly into the small intestine. The small intestine is made up of three parts. Number one, the duodenum. Number two, the jejunum. And number three, the ileum. The duodenum is a very, very short part, but it's very important because it's bringing in that chyme and it's mixing it with a number of other chemicals that will come, number one, from the pancreas, and number two, from the liver. And so we'll talk about that as we go through when we draw those out on the board. That chyme then enters into this little piece of tubing system right here called the duodenum. Again, the duodenum is the largest place of the breakdown of protein, plus it's in the initial area in which you'll find most of the lipid breakdown, okay? From the duodenum. Into the jejunum. And then into the ileum. Please make sure you understand ileum is I-L-E-U-M, not I-L-I-U-M. The I-L-I-U-M is found in your hip. This portion of the small intestine is where we will find 80% of the absorption of the macromolecules that you bring in through your food source every day. Again, very, very large in its tubing system, as long as 20 to 25 feet, depending upon the size of your patient. We'll also find the very special features in that area of villi and the microvilli. We've seen them in the lab, and we'll take a look at them as we go through the lecture series, okay? But those finger-like extensions increase that surface area to really provide a lot of additional surface area